Hello. Okay, I think I can see there are a few people have joined. So before I start, can you please start typing in the chat that you are there so that I can, understand that how we are doing and from where you are if helpful, like maybe your name and where you are joining in. So I'm doing this for the first time. Spare with me if anything goes wrong over here. Okay, so we have 16 live now. I'll quickly start without wasting much of your time. In the meantime, if you can add your location, that would help out to understand, that how we stand. Either are all from India or outside. But anyways, I hope you can see my screen, which is good. So basically, here we start. So agentic RAG and event-driven development. When I speak about it, okay, so there are many things which are critical here, because when I say critical, you might have seen that a lot of development is happening in AI, and not much is the ROI or the outcome which is coming from it. Okay, and there are many reasons for it. I'm going to give you this brief history so that we understand um, why we are having this session now. And this is all coming from my experience, so there is nothing I am um, just saying it for the sake of it, but I have lived this experience, and that's where I'm trying to help you out as well, to don't do the mistakes which I did in the past or many engineers do. And they are at a state, most of us are at a state where there's a lot of AI failure, AI junk, AI slope is being generated. And to avoid that, this is one of the steps which you can do to get better. Okay, in most of the cases, AI is getting. I mean, everybody is generating with AI, and they look good in demos. The problem with that, they don't have a knowledge, under the hood knowledge, which they need in the first place to scale it, to make it scalable. And that is the biggest reason that AI is failing. Not because AI technology is failing, but people are rushing towards the outcomes. And in fact, when I say outcomes, the only the demo part, not the, they are not thinking from the infrastructure side, they are not thinking from the engineering side, they are not thinking from the platform side. All they are doing at the moment is, when I say they, I mean everybody. This includes me as well. I fail at times, which is quite okay. But the idea is to learn from your failures and to understand what and how the AI should be implemented in the first place. Okay, and before even jumping to the code generation, gone are those days where we used to generate code, or rather write code sitting, and it was the most cumbersome effort, and that's why it was most paid uh, in those times. You will get paid more if you do better coding. So by virtue of this, over here now code generation has become secondary, but because we all know LLMs are getting better and better at generating the codes, but the engineering part is missing now. Everybody is focusing on these particular demos where they generate, they understand what is RAG and they create RAG. Okay, as simple as that. But that is not something which is happening in the real world. So this is the background to start this session overall. And when I say this session, I mean this is the first day, I would say, where we are going to build our first agentic RAG system, or you can simply call it agentic system. But the whole idea is to add evaluations. It's to make it eval driven development, and the whole idea is to have every possible thing in place to make it success. Okay, so that is the whole idea of this series. There will be a lot of learning if you continue this journey, and I would really want to thank many of from our QA community. I'll come to that for now, but yeah, this is my LinkedIn profile. You can connect me if you want, and if you have any doubts, you can connect me directly as well. So this is day one. We'll start from here. There is a lot to add here, which a lot of things you might have heard, you might have not even heard or known at all. So that is going, and that has come from ample failures. So that's where this is going to help you a lot, and I can bet you that. Okay. Now I would really want to thank the community partners, QA Bash. I mean, obviously, most of you are from there. Um, so that is something very vibrant. Everybody helps everyone. So that is kind of um, situation over here. You come here and you get help. I would like to especially want to thank a few members of it. I may not be in a position to take all the names, but Ishan is helping out a lot. Gaurav is there, obviously, and I don't know the name, all the names, but there are a lot of people. Okay, sorry if I'm not taking a name, but please understand that we all are helping each other over there. Okay, now there is another community which I am actively part of, just like QA Batch. It's Indian Data Club. If you want, you can join this club. Sahib runs this community, and he also organizes events, meetup, workshop projects. I've been in touch with him since a long time. So you just talk to him directly via this community, or if you can take my name, he knows me well. So that way you can connect to this group as well, and lot many things happening to this community as well. And I'm also active part of the both the communities. So feel free to join. Now, I'll quickly start that why we are having this in the first place. Okay, where we are heading, and I'll briefly talk about little bit of history because that is going to add more information. I don't want to make it theoretical, but still I want you to understand that why this is happening. Okay, at this point of time, why now? Okay, so this is all across 30 to 35 years of a journey where softwares have helped human to find information. Now, understand that when the internet arrived, there was a lot of information, okay, but you need to find it, find the information. You may argue that search engines, which I'll talk in next slide, but you need to find the information, and that is the most hard part, right? During that time, imagine like finding the information on the web without any search engine. If I give put you in situation now, how how you will be. Okay, can't imagine. Then understand this is the biggest challenge. Okay, you found the information, even though information is correct, but you don't know how, how it is. So understanding is one of the critical and time consuming parts where there. Now we have, given all this thing to AI systems. Previously used to decide and take the actions. Now we want AI to do this, and that's where we are heading. Okay, now this agentic RAG lives in not only answering but to working to act upon. Okay, this is how we have moved from one generation to another. Now the very next slide speaks about every generation has solved one problem at a time, but it has exposed the another one. Okay, in 1995, search. I mean, I just now told you, right? Search came into the existence where you can directly Google or use Bing or whichever way available there, and you can find the information. Okay, so that way Google also took is advantage, and now it is a very big company. Then enterprise search came into the later existence, and this was limited to the internal documents which are very critical to an organization or for any entity, right? So that way it headed. In 20s we have LLM, where we reason in language. Okay, we have language. LLMs are very good, prone to be very good in language generation and language understanding. So that's where uh, the whole world has changed. But then there were some limitations, right? You don't know, LLMs don't know what to find. Then RAG come into picture. Now humans are very lazy. They want AI or LLM to take the actions as well, and that's where the agentic RAG came. And now we are at a state, everybody is building, but nobody is evaluating to an extent to the in a right way, and that's where a lot of research is happening these days. And there is no concrete solution for this, to be very honest, but you can fix it. I mean, the solution is you start fixing what could break. Okay, and what you don't know, you don't know. So that's kind of a situation we are into. Maybe you can assume, but you don't know, right? Reality, 100% you cannot say that, okay, if this, to fix this I will do this and this will work. Okay, you cannot do that. But there are certain things we can do, which I'll teach you if we continue on this series, how to do that. Okay, now over here we are going to, I'm going to help you with a smallest useful um, kind of a solution where we have one agent and a knowledge base and a couple of tools only, or a few tools. I don't want to you to put yourself in a position that, oh, I missed this, this is so much code I don't understand. No, we have very simple implementation, we have very simple knowledge base, which just by looking at you'll understand, and we limit ourselves to few tools. Now this is, if you ask me, it is what we do in production or enterprise level, maybe not, but the direction is there. Okay, you need to continue in this direction if you want to implement these things in the production level. Okay, now over here I have spoke a lot about the where we are heading, and what we are doing. So this is over here we are again deliberately building something which we need to later evaluate. Now whatever I spoke about, it's available in this slide, which is now refreshed, I think. And now over here whatever I have spoken so far, it is available, but I want your attention on the key milestones here in 2018. If possible, then by the way, if you have any questions in between, you can simply post in the chat. Then that, if I could, I will answer, or later I will try to answer that. Okay, now in this slide I want you to understand very critical key milestones, and if time permits, or rather if you are very curious and if you are very much in a position to do this, please do this. Okay, if you can, then it's a must. So for example, transformer attention all you need. Okay, this is the research paper. Then RAG research paper. Now there are always version keep on changing, so the year may not be remain same. For example, RAG paper was reversion, so you may find 23 RAG paper, but that is okay. So they have added some more information around that. Now tool former, this is one of the finest paper, or rather, if not finest, but but something which changed the entire LLM industry, agentic industry. So this is the research paper, tool former. I'm going to show you this research paper, by the way, and if possible, I'll give you the links as well in the communities. React paper. Now from tool former to React. Now these are the two stepping stones of the agentic AI. React, you may have heard a lot about this. I'll speak about it a bit, and this journey is very clear, right? So with evaluation, that is what happens, right? You understand something, you find the problem, you try to fix the problem, you create something else. Then again it repeats. You understand what is newly created, you test it, you use it, you will find problems, you will create something else on top of it. that is how the evolution happens, right? We all know that. So this journey is very clear. We know the language, we have the access to the knowledge, we have the tools, we must reason in the loop. I'll come to that. We orchestrate the workflows, we act autonomously, and that's the whole industry is all about, the agentic AI. Okay. Now, before I jump in, I want you to see this, okay, which I'm sharing now, and I hope this is visible. There could be some lag of few seconds, but that's okay. Now, these are the papers I was talking about. Okay, if you have time, or rather, I'll again repeat that statement, that if you have time or if you are willing to deep dive, then these are the research papers you must read. Okay, there is no understand basically, if not only read. Thank you, Ishan, for updating that there is no lag. Um, this is one of the finest paper. If you don't understand, put it in LLM and ask it that simplify for me and help me understand this research paper. Okay, this is the whole thingy where we are, or in which situation we are. That is the reason transformer paper. Okay, so I always talk about this. This is one of the most cited paper in the AI space or in the technology space. There are a lot of citations. Everybody refers to this what do you call the paper. And when you go for an interview, let's say, be it evaluation AI evals, or maybe an AI engineer go for it, there has to have understanding of transformers, and people ask questions about this paper as well. So that's where this is very critical paper, I must say. I mean, block 30 minutes of yours, give this paper to AI, create a video around that, or whatever you can do, um, just to understand this better. Just do it. Okay, this is one of the finest paper, and whatever we are. When I say finest, I mean it's a game changing. Now, another paper which I was saying, that retrieval augmented generation. Okay, now this is the research paper from where RAG got his attention. Okay, now this paper have also a lot of information around RAG, and how it's not only RAG but how the mathematics around RAG which goes. Okay, how the RAG token model works, how the RAG sequence model works, how the retriever works mathematically. Okay, I mean, if you're interested, you can understand and read more about maths, if you want, if you're curious. And but yeah, but this is something which this research paper have helped me a lot as well to understand far better about RAG than what I knew, or what and how could I implement this. Okay, so this is the second research paper I would recommend you. The third research paper is tool former. Now again, this is, you can say, this paper gave the direction. Corporate Majduri. Yes, I can summarize. Okay, but let's for now focus on what we have in this session, and then I'll if time permits, I'll explain this, or I'll maybe we'll go again with these papers. Okay, um, because this needs serious time. It is not something that so this is not something that I can simply talk and done and dusted. Okay, but I can give you some one-liner briefs, and maybe if you want, we can connect again on this particular thing. Now, attention is all you need. Now, this is the paper by Google. Okay, imagine something Google created, but ChatGPT capitalized. Okay, or OpenAI capitalized, I would say, and then everybody capitalized, and then Google realized that, oh, this is, it's like a chess game. You Google played the first, I don't know what to call it, the first move, and then Google lost the way itself, right? And in the chess, then OpenAI, Claude, everybody went ahead, and Google finally realizing that it has created gold, but without even knowing that. Okay, or maybe without even applying that gold in their, keeping their gold in their vault. So that is how the little bit story of this paper. Um, Again, this is not the right time, but this might have been revised. There's a lot of research happened. The Google Brain team, which gave a lot to this paper, and now I'll explain you how this works basically very briefly, and then if you want, we can connect later on this. Now, this is the architecture basically. Um, Now, what happens? Okay, if so, there are key concepts let's talk about. There's a multi-head attention, okay, and feed-forward networks. So these are the two things for now I'll help you understand, and then later maybe we can have everything which we can take. By the way, this is the full transformer architecture, and one important aspect, not everything is full transformer architecture, okay, and that's very interesting. So chat gpt is, I believe, and I may be wrong here, but it's a encoder only architecture where you give the input and expect some of the output out of it, again in the probabilities which eventually generate the text for us. um, and and Gemini or Rabat, the previous one was basically the decoder only architecture. Okay, so over here, what happens is you give some text to the LLM, and LLM only focuses upon the important parts of your sentence. So, for example, I'll tell you, "Hi, my name is Tony Ramchandani." Okay, now I'm talking to you, so you hi and all those stuff you'll ignore. You only focus on my name. Might not be on my last name as well, because maybe you can give more weight to my name, not maybe to my last name, or maybe not. Okay, depend on the person, let's say. So that weightage is the attention part basically, uh, in a way. Okay, not exactly, but in a way. So that's how it goes. Okay, I'll explain this if you want later, because it will just eat out that a lot of time. um, Now this RAG research paper, this is quite obvious how they invented the RAG kind of a thingy, where they gave bunch of the documents to the encoder, and then they expected some of the outcome, and results were better than the LLM. That's how it was. Like LLM may not have the latest knowledge, so you provide those documentation. So we know about RAG in a way, so I'm not putting a lot of um, effort on this for now. Okay, now tool former is something which changed the direction of the agentic systems over here. It's basically the simplest idea, kind of a functional programming, right? We used to do, right? We used to create function for everything. Very small thing, we create a function, add two variables, create a function, and that's how this idea came into the existence, that we'll create simple tools, okay, or maybe a basic tool to an LLM, and we expect some outcome, okay, out of this. I think RAG was already there, so there will be some research papers on tool former with RAG as well, which will help you understand more. But that's the whole idea. It's kind of the foundational programming we started, right, when we started learning about programming. So you simply give a very simple function. For example, in this case, the wiki search they created, and they gave like something Brown Act. I don't know what is that Californian law. I don't know. I'm not aware of that. If anybody is aware, type in the chat. Um, so basically, it answered about calling that tool. It uses the LLM and simple tool call. So that's you can call it a very simple tool call, not complications, nothing else. It's small tools which do very simple thing, just like our modular programming. So for example, over here you have the LN language model dataset. You call the simple API, execute the API, you filter your data, and then you, like, what you're doing is now LM dataset with API calls available. Okay, so that is something which happened. And again, if you are love math, then this is going to help you. Like if you're doing serious research, or if you are doing something very limited to creation of LLMs, or creation of such things, then you might be interested in maths as well or writing any research paper. So this is something which will help you. Um, Again, I'll just repeat that we can connect on this if you want. Now, tool former, this is the same page. I think I've opened. Okay, now this is something which changed the entire landscape of the LLM agentic. Now React, so basically reaction, reasoning plus acting. Okay, that's what we do in real life as well. I mean, if I give you a bunch of things to do, you will think out loud and then you will perform an action on it. Okay, it is as simple as that. Let's take one example from this research paper only. That now now what goes inside? Okay, yeah, so let's say a question that aside from Apple remote, what other devices can control the program Apple remote was originally designed to interact with? Okay, so answer is iPod. If you ask a simple LLM, if it says iPod, then I mean what they did testing was screenshot they've given the screenshot of that. So LLM might have answered iPod, which is not correct. Okay, now they went ahead with COT, chain of thoughts prompting, okay, where they only reason and they try to identify whether COT helps or not. Okay, now chain of thoughts is again very good type of prompting. It needs a different session in itself. Let's think step by step. Okay, Apple remote was originally designed to interact with Apple TV. Apple TV can be controlled by iPhone, iPad, iPod, iTouch, whatever. So the answer is this, but this is not the correct answer. Okay, and now um, now the next section comes is the act only. Okay, so now it uses uh, a tool which is a tool from a, let's say from the research paper. So it searches for the Apple remote, so it gives you some observation. Okay, when we search about Apple remote, you have certain observations. One is this, the other one is this one, could not find front row or something like that. And then you search again, you find the front row software. I don't know what is their internal mechanism of searching, but yeah. So it it says okay, finish, yes, but again it did not give me the answer. It is simply calling a search tool and it is giving me something which is not helpful to me. Now then they did the very same thing with the reason plus acting. Okay, so so it is similar to how we react to any situation. Okay, kind of. So so we first give some thoughts, okay, and then we act, and there's some observation. So when you act, you will find something out of it, right? You observe. Now either you need a thought two. If you have a thought two, then you have to repeat this, like act two and observation two, um, and then thought three, thought four if needed, thought 10, right? So and then it produces the output. Okay, so that's that way the agentic behavior was established within the LLMs. Okay, now this is again the research paper, which is very good research paper. um, I'm not going to spend a lot of time now on this, but agentic design patterns, um, again a research paper which was revised, but it will give you a lot of information around how the design patterns can be adopted in the agentic AI systems. There is a lot of information. If you click through these links, you will find more research papers which will give you like a, a way of working on these things as well. Now when you read research papers, just think of it like it may not help you to implement something, but it will help you to understand. But by reading research paper, most of the times you don't understand, so use an LLM. Okay, because they created research paper with some prerequisite of their knowledge which they only and exclusive to these people, or rather very limited people. But when we read such kind of research papers, we don't have that background. Okay, so it most of the times, yes, I'll share the links. Okay, so most of the times these research papers are people's, I mean these are scary. People run away just because they don't understand. Okay, now, and they don't think through the process that why don't I understand? Because while somebody is writing the research paper, that research paper has that person has some background knowledge around that, and that's why he's in a position to research around that part, right? So that person expects that whoever is reading this or reviewing this must have some prerequisite. Now, and it's not that just leave that apart. So there's a lot of references and furthermore research papers or URLs they give as references, which if you want to build that kind of a knowledge, then if you follow those research papers, it will help you gain more knowledge around that part. That's how it works. Okay, and most of the times we are scared, which is okay, don't mind. Okay, just put a habit of um, reading them or understanding them with the help of your colleague or LLM or them anyways. Okay, to start with. Okay, and once you, but I can assure you, if you start reading research papers, your knowledge will exponentially grow after a point. So there will be a threshold point where you will be in a position to, you will be in a position to understand what the person is researching about and talking about. And when that point is hit, your knowledge will be exponentially increased. That I can bet you. I have many a times I've seen people, and I have experienced myself as well, that over the period of time it just helps. Okay, there is this another important survey paper on the agentic RAG. Now, this is going to give you a lot of information, which I have just now spoke, that how agentic agent works, and what we are implementing is um, a simple tool kind of a thingy, right? Just because we, I want you to understand this, but if you see here properly, this is the diagram which I want you to focus a bit, that what all the frameworks are available: LangGraph, Llama Index. Now again, you might add more there, but this is something which handpicked by the writers. Semantic Kernel, Crew AI, Amazon Bedrock. So these are the certain frameworks which you can use. My often choice is LangGraph. I'll go with LangGraph, which helps me a lot. It's easy to learn and implement as well. Today we are not doing that because I want, again, it's has to be very simple. Okay. um, RAG challenges hallucination and inaccuracies. We all know this. Okay, we, you might have heard about this. What are the LLM challenges and limitations? Some of them apply to RAG as well. And then the agentic RAG, how it overcomes. I spoke now about the observation, thought, and all those stuff that goes inside the agent. Okay. Now, there are like the types of RAG are like nav RAG, which everybody might have heard of this. If not, please understand that you give some external sources to LLM, and LLM read those sources to help you with the answers. Okay, so that LLM does not hallucinate. So maybe you ask something that, okay, who is the father of X, right, Mr. X. So LLM will potentially give you an answer because that has trained to serve people. Okay, even though he or the person may not exist or whatever, he don't, the LLM, it don't know about that, but it will still give you the answer, supposedly. Okay, and that's where this RAG came into picture. Then advanced RAG, uh, getting resound. I don't know what is that resound. Is it my sound okay? Please, guys, others can, anyone. Oh, why that? It was not there earlier, right? I hope. Oh, okay, okay. Is it fine now? Okay, I think so. My phone was there probably. I'm just checking how it is going on my phone, so that's where um, might be the disturbance. Okay, anyways, sorry guys for that. I'll quickly come back to this, and then we'll start. We'll move back to what we have. I hope this is getting helpful to you as well, to understand more intrinsics about the AI and the LLM. Okay, I'll try my best. Um, okay, so I'll just close out this architecture diagram, and over here we have this like modular rag, graph rag, a lot of rags you can implement, and there's hybrid rags as well where you can put a lot of combinations, permutation combination, and you can create your own rags out of it. Um, Agentic workflow patterns. This is something very important. Prompt chaining, routing. So we are going to use a router as well today. Orchestrator workers and parallelization. So that is more complex. You can add layers and it will become more complex on the on those sides. Okay. So um, let's move on over here. Enough time given to this because I want you to have a clear cut understanding of why we are in the place today. Uh, okay, and that is something which needed the help. Um, Consider this analogy where traditional RAG is basically a map. This will give you information, but you still need to decide how to handle traffic or where to go reroute or not. Okay, reroute is something very important here because if you take action and it goes wrong, then there are the consequences of it. But agentic RAG is like a GPS, right? It will give you the proper understanding whether we need to change our route or not. Monitor progress and tell us what exactly we need to do in this particular situation. So this is the analogy. Please remember this just for easy understanding. LLM or a RAG, simple RAG is a map, and then this is the GPS. Okay. Remember this core mental model. Whenever you are working with AI, okay, whenever you are using LLM or talking to AI, just understand knowledge is not equal to a decision, and decision is not an action. Okay, most of the people fall here and they create certain demos and they feel proud and they just showcase, but they when they try to scale it at the enterprise level, they fail miserably. Okay, just because there's an excitement around some implementation because they have certain knowledge. Okay, that is the worst part, trust me. Okay, so just remember, always remember this: knowledge is never going to be a decision, and your decision is never an action. Okay, knowledge is knowledge layer. Just keep it simple. Knowledge layer which you need in your solution is what your docs say about, documents say about, what is the policy contain, what is the evidence that exists for this particular knowledge. Decision layer, what should I take decision, should I take now, which path to go. Okay, is this evidence enough to take this decision or not. Action is properly like checking an order, creating a system ticket, escalating a human. Okay, these are three different things. Most of the time people mix this and they fail miserably. Okay, it's very small thing, we all know by the virtue of it, or rather we all know in general, but we fail here. Okay, when we implement the real world solutions, we fail because we see some outcomes and we are somehow convinced, or we convince ourselves most of the time that okay, we are good, but no. So just keep a distinction between these three aspects. Okay, now where these basically what are the same. Good one, Gaurav. I think this is the meme you should keep this Friday, or maybe you can use the Sunday for that as well. Okay, so basically this is something which is happening across industry. Okay, in support, in healthcare, finance, and legal. These are the basically four buckets where most of the things we implement and we fail because my suppose my package is late, right? So you not only need to answer that, but you need the order status. You need to know the policy. You need to know the LSA. You need to know the customer context as well. You need to understand whether you want to escalate this or not. You need to understand whether you want to give a refund or not, or replace the system, the item or not. Okay, so that is something which is very key over here in this case, and this changes with every industry. Failure could be the same, context may change, but these are certain things which most often fail. Okay. uh, Now this is classic rag, we spoke about this. I'll just keep this. Those are just to these exist because I want you just to reiterate, and with reiteration you may understand, or rather, it sticks to your mind most of the time. So some of the things are intentionally reiterated. Okay. um, why RAG fails most of the times? Because the context integration, multi-step reasoning, okay, and the operational actions. So in this case, the RAG fails. I'm not going to put a lot of time over here. Now, what we are doing today, okay, now this is something, understand this architecturally, and then we are going to implement this. Now, this is our framework. User message, like ask a question, user ask a question to our system, then system, there is a retriever which is going to retrieve the knowledge from the knowledge we have. Okay, I'll show you that. Then use tools, will allow access of a couple of tools to the LLM, and we'll see how these tools are used by LLM. So that is because it's agentic, right? So LLM has to use the tools, and but why, sorry, how the LLM will use the right tool, that I'll tell you what are the some basic needs, which basic checks we should do. Ask for the clarification if have to, and then escalate to human support. So these kind of the this is the layering which has to have, and and it is directly connected to the knowledge base, any order API if you have for history, and details and all those things, and a tool ticket engine where where you a ticketing tool engine where you create the tickets, support tickets, and then if you want to hand over to human, then be it. Okay, and then we get the answer out of it. Okay, now this is again very important thing to understand. People often confuse um, with agentic behavior and workflow structure. Okay, now agentic behavior and workflow structure are two different things. People mix most of the times, but there has to be a clear definition around that part. um, Agentic patterns are basically what kind of thinking exists, right? Reflection, planning, tool use, multi-agent collaboration, and you can add more memory and all those stuff over there, but the whole idea is that remains to very much in the context of agent only. Now workflows are routing, rerouting, prompt chaining, parallelization, okay, and then evaluators and all those things which comes into your workflow. Now how these are different, um, when a so the workflow is triggered, okay, this may call to an agent via routing or rerouting concept. Okay, then agent perform the action which is on the left hand side. What is the output? Then the right hand side will take care of it. Okay, so think of it as a ring road which is surrounding the city, and within city the chaos is happening, which is the agentic pattern. Okay, just think through that analogy, and and we'll use tool use and routing over here. Okay, and now where we stand in our day one. So today I'm going to talk you or take you through about single agent router. Okay, multi agent, we'll do it later. Hierarchical, corrective RAG, adaptive RAG, everything will go later depending upon how the interest of the people in learning goes. And um, and graph kind of thingy, graph rag, which is more advanced, which goes hand in hand. You can create the hybrid rags on top of it, but this goes for later. I don't want you confuse with a lot of terminologies over here. Okay, so I'll quickly jump to, there are certain slides which are intentionally written in a way that it's a mirror of something else with some different analogy, but just to repeat what we understand, okay? Because it's very important. I want you to follow this thing, that one way of understanding this, again, after some time it comes to a in front of eyes, then we remember for longer term. Okay, that is the whole idea in a way. Okay, or sorry, I think, yeah. So now speaking about this repository, I'll quickly open my, yeah, browser. Okay, so this is the repository. I'll give you the link of this, or else you can go and search for Agentic RAG and evaluation on GitHub with my username. You will just a brief RAG. Just what is RAG? Okay, yeah. So RAG is basically retrieval. Okay, I'll explain this with one slide I have. Okay, so I have that as well. I'll just quickly use this now. I knew it that there would be some question around that part. So let me take you through this. Okay, and I hope this will help you a lot. Now, what happened? Evolution of language models. I'm not talking about large language models here. I'm talking about language models. Okay, the way we interpret, or the language models um, are created or understood. Okay, so they were n-gram models, bigram and trigram, no word representations. Okay, so very simple mathematical way of language representing the language models. Okay, one second, guys. Okay, very simple way of representing the language models. Then neural uh, language model came into the existence, word to vec and glove. These are the basically static word representations. In this case, you can give like the concept of embedding, you can call, which came into the existence over here. Okay, where you can give a proper number in a mathematical space to any. I'll talk a little bit about embedding as well, because since there is a question, so I should answer that before jumping to the implementation, because that's the whole idea, right? You should get more understanding before implementing. So what are embeddings? Basically, everything you can uh, imagine a space of, I don't know how many, what you call, layers. Like it can be like 300 or 400, 500, 1000. Okay, in those layers you will, or other dimensions, not layers, you put every word over there, and there has to be some aspect associated, and there will be aspect value. So now I'll take this with example, apple. Okay, apple belongs to fruit category. Apple is sweet, sometimes not. Okay, but let's say you can eat it in the morning. Okay, this is one another aspect. Apple grows on a tree, it could be third aspect. And apple is red in color, let's say, so the color is another aspect. Okay, and apple have seeds, so it's another aspect. So you can put a lot of aspects to judge something. Okay, now that is what embeddings is. Now these word to vec and glow are the traditional way of creating the embeddings around the words, or other things, like apple. In a way it's a word, so you give some value. So for example, taste, you will give some value out of 0 to 1, right? And then for color, you will give some value out of 0 to 1. Let's say redness, how much redness from 0 to 1. So that way you can imagine that space of thousands or hundreds of aspects. It will fall somewhere, right? It will fall somewhere in that space. Now because it's a category of fruit, you take another fruit, let's say cherry. So cherry may be a little bit near to apple. Okay, but papaya would be far from apple, even though it's a fruit in that space, right? So that's how you can place each and everything, every word in that particular space by giving some value to every possible aspects of understanding that. Okay, that's how embeddings is. Okay, and from there, the context of a representation came into the picture. Now, why I'm talking about this? Just to answer what is RAG over here. Okay, because that's the question came. These BERTs and GPT models, which we know, which you're using. Okay, now uh, this is something that um, how the LLMs are deployed. Okay, which for now I'll just keep, but I'll, yeah. So I'll explain this now. Okay. Yeah, so this is actually the RAG. Okay, by this diagram, you will understand the RAG. Now, see your LLM, or rather whichever LLM you are using, it does not have all the information, right? It was trained. Okay, so this is something. This is the diagram how it was trained. Okay, you gave some data, you did some pre-training, and then fine-tune that particular the model which was created after pre-training, and then you did the preference data set. Okay, now what is preference data set? Basically is how you want your LLM to answer. You set the preferences. So that happens. We don't know internally how ChatGPT does that, or Gemini, or whichever model you are using does that. But they set the preference, and that's the only reason LLM doesn't go rogue. Okay, you ask ChatGPT that I want to hack a bank, it may not tell you. Okay, there could be prompt injections you can give, but so far this is the preference data set which helps you to create something. Yeah, Gaurav is always great explainer. So preference data set. Okay, I'm going a little bit backstage. If you have any question, you can just simply type it. I'll help you understand that. And then the alignment evaluation happen, and then the LLM, or rather the GPT version, is available for you to use. Okay, that's how it works. At very bigger level, there would be many such tasks which even we don't know could be happening at different levels. Okay, now this is RAG. Now we know LLM, how LLM is created. We have certain internal documents, okay, which we want to process. Now, LLM may not know about that information, right? Maybe, for example, your medical reports. Okay, let's say you want to create a local LLM on your medical reports, and you want to understand how your health is. Okay, ChatGPT or Cloud don't know about that. Okay, you give those private data. Okay, you bring in small chunks. Now, what is chunks basically is, because see, ingesting so much of the data, LLM may not find it relevant. Okay, so there is something called as chunks, where you just broke I mean put your documents into small chunks, and then pass to an embedding model. I now just now explained you, that's the reason I spoke about it, because that's how the language is converted into the mathematics, and mathematics is understood by the LLM model. See, this is the embedding vectors, one example, not a right example, but just to make you understand that every aspect gets certain value from 0 to 1 or -1, however, depending upon which kind of embedding model you are using, glow or vector, and there are many more. So uh, okay, if it is going, I don't know how to fix this now, because I did everything which I could. Okay, yeah, so basically this pass to an embedding model and then produces the embedding vectors. Now the whole idea of embedding is to keep similar things together. Okay, you can say in a way that fruits will should ideally be located in fruit section, and a gym trainer or gym related things, uh, okay, laptop is good, so should be in one uh, in a proper context where the relevant things are available. Okay, now to store this, we have vector databases. See this kind of information. Now what you see, the transformation, you have certain text document, PDF or something, unorganized data, you broken into chunks, you pass to an embedding model, and then embedding model produces the vector embeddings. And to store that vector embeddings, we have the vector databases. Okay, we are going to implement Chroma database today for understanding. Now now this is critical because now we have our document in a way that LLM ideally should understand. Okay, so that is something we have in place now. If you still have any questions on this, please put in the chat so that I can explain it. For a second I assume that these definitions would be known, but yeah, thanks for highlighting that. Then the retrieval. Now this is again important. When user asks some question, this is processed by same embedding model. Now this is very important because these embedding models, we are going to use sentence transformer embedding model, which is very lightweight and free to use today. And these embeddings models is should be ideally processed by the same model because they are almost equivalent or same, but there could be some internal changes in the embedding. So for example, what I'm trying to convey, that let's say model X is generating the embedding of 3 digit, but model Y is going for the fourth digit as well. Okay, so there could be certain, uh, although they are in a way mathematically right, but may not be producing the correct output. Okay, and that's where you must need same embedding model for the output as well, the one which you use for the input. For the processing, you use one model, and user's query, there has to be embeddings. Also allows faster searching. Yes, comparatively, but there are limitations. Okay, so we'll see. Now that's how the vector databases are queried, and then it goes to the LLM, and the LLM beautifies or whatever the answer you want, it converts, forms that particular language, and that's how the generation takes place. So this is the architecture of a simple RAG. Okay, where uh, you have this particular data as in the form of embeddings, and those embeddings are queried by the vector databases, stored in vector database and queried by the LLM, and then the LLM gives you the answer. Sorry guys, I'll just, yeah. So now I'll come to this where we shifted our course, okay, a bit. So we have this agentic RAG evaluation available under this, okay, and basically this is fairly simple to understand, and that's where we started. I have already loaded this in my VS Code, but I want you to read this, read me as well. I'll help you to talk a bit about it. So first of all, um, we are creating the order support agent. Okay, now in this case, it is fairly simple. That assume that we run a shop, and we are going to deliver products to our customers. But in this case, uh, the the order support agent is something which is going to help us to handle our e-commerce support queries. Okay, customer queries basically. Now it has RAG, which we just now spoke about. It searches through the policy document and tries to provide, this is not a correct line, but tries to provide the accurate answers. So basically, um, there are certain, obviously there will be some policies while talking to the customer or creating something on top of it. uh, Thank you. Let me just tell you. So for example, this is the, okay, I'll now switch between my code and the GitHub or repository or anywhere. So please understand that's just for explanation purposes. So for example, this, I have created this folder which is the data folder, and I have some information. Now this is my, you can say, data storage, and you can create Now you can organize the way you want. Okay, this is not a problem, but let's keep it simple. So we have FAQ. So FAQ is quite simple. How can I cancel my order? And you can add more FAQs. You can modify answers and all those things. So this is your source of truth. Okay, where your company oriented policies are setting. May not be the policies, but the frequently asked questions. Okay, how can I cancel my order? Order can be cancelled before shipment. Okay, you cannot cancel otherwise. What if my package is delayed? Check tracking first. If delivery is significantly delay, contact support. Now these are very straightforward ones. You read, you will understand. Okay. Now this orders.md file. This have some sample orders that where are we and how it works basically. So for example, the order 104 is status is cancelled. What is the item? Gaming mouse and keyboard. What is the shipping address? And what is the order date? What is the tracking number? Okay, this is a simple database I have for my orders. And then return policy. So whatever is that you can modify according to your need. But this is my return policy, let's say for my e-commerce business, which I don't have. So customers can request a return within 30 days of delivery, so on and so forth. I'm not going to read through a lot, but this is simple, very simple. And then we have shipping policies. Now you can add more policies, you can make it more complicated, but let's start small. Okay, and that's where this data thingy happens. Now when we spoke about RAG has to look through these documentation while answering. Okay, this is a simple thing to explain RAG, that this is my data. Instead of answering randomly, go check my data and answer from it. As simple as that. That is the simple definition of RAG. And how it happens internally, that this is going to get converted into embeddings. Every word is, it has a mathematical number, and then that mathematical thingy or an array of mathematical numbers or a list, then that array or list is going to be processed by the LLM, because machines are good at maths. Okay, and that's where they understand this quite well. Now I'll come over here. uh, what our solution is doing, basically it's RAG. So we have the RAG in place. We have function calling. Function calling is for executing the tools which we have for, let's say, ticket creation and order lookups. Multi-provider support. So multi-provider means you can switch your model, GPT model and Ollama. Now this is important, because most of the times, people use single LLMs and they and assume that LLM is down. Okay, OpenAI is down, then your model should automatically switch to some other model. Now, automatical switching is not what I'm doing here, but I want to tell you the idea of multi-provider support. Okay, this, when you design your agentic system, this has to be the first choice. You should have a multi-provider support. Okay, it's not that you can depend on OpenAI for your business. OpenAI is down, you're gone, right? You're gone. You don't get a lot of, I mean, your business will be down in a way traditionally. Okay, I'm not a business guy, so you understand what I meant. Rich CLI. Now, if you have ever used Python and if you want to get beautiful output in your terminal, so for that Rich CLI is there. It's a simple plain Python library which I've used. There are multiple alternatives and make it more beautiful, to make it more beautiful, but this is the simplest one I used. Okay, and what can I do with this? So I can answer the questions basically from the customers around the shipping, refund process, so on and so forth. It can perform actions. It can look up for the order IDs. It can create ticket for your issues, and it asks for the clarification when needed. Okay. Now it can run two ways. Either you can use cloud, which is OpenAI's GPT-4 or whichever model. I mean, okay, and you can use the embeddings model of OpenAI, which is very powerful again, but it will cost you. Now you can run completely offline with Ollama as well. So the only challenge there would be is uh, Ollama would run a bit slow if you have a slow machine. Okay, but I'll flex that I have this new machine, so this helps me a lot um, to save cost around the open API and all those stuff. But I'm using Ollama in this case, okay? And I'm going to tell you, if not Ollama, then how you can use OpenAI APIs, which is simply fairly straightforward. Okay. Now these are the core capabilities. Now this is our architecture. Okay. User input something, let's say check order ID this, and then order support agent manages conversation history. Okay. Now this is important that we are not introducing memory so far, but we are storing the conversation history. As soon as you close the terminal, the history will be gone, wiped out. Okay. Reason being, uh, conversational history is important because if I keep it, if I don't keep it, it will be a dumb assistant. Okay, it answered me previously, now it will forget. Conversational history is just limited to that conversation, and once it is done and dusted, the state goes out off, and then it is not storing for now. Okay, because memory I don't want to introduce intentionally. Memory is a separate topic, and if I introduce here, it will again add complexity, which I don't want you guys to start with that complexity. But memory itself is a session in its own. Okay, there's a short-term memory, there's a long-term memory. By the way, for memory, mostly these databases, the vector databases are used mostly, or could be the hybrid graph databases or these vector databases. Okay, these are the mostly used or widely used memory things. I think mem0 is one of the framework which is widely used for memory. If we'll add that later, but for now it will um, orchestrate the tool calls, and then open API provider, in this case GPT 4.1, because I want, if you're using this, I want you to save your money a bit. For Ollama, I've used 3.2 model Llama, which is good and powerful within the local systems. And either you can store local only embeddings or Chroma database. I'm using ChromaDB for better usage, and it's not that heavy as well. Okay. Now what it takes basically is the knowledge base, which is the data part. In the knowledge base, remember there are orders, but my knowledge is only limited to FAQ, shipping policy, and return policies. My order knowledge is something which is added on top of it. Okay, not something which not something I wanted to be in place, because there could be no orders, zero orders in the first place. Okay, and then tool registry. Now this is very, very, very important aspect. Nobody is going to talk about it, but I'm going to tell you how to implement this. Now, tool registry, what is that and why it is so important? I'm putting a lot of impression on it because most of the time people simply forget to do a tool registry. So when you do this, and that's where things happen, like hallucination and all. When you put your tools in a tool registry, okay, tool registry can be in multiple ways. Either you can create a Python data class which will automatically do it for you, or you do a manual entry, or there could be create a separate class for implementing tool registry, and there are pros and cons. But in this way, a tool registry, okay, one question out of the curiosity, how do the system identifies that the question coming from the user is not at all related to the system, and the system stop consuming that token? It will simply answer that. I'll tell you. I'll tell you. Okay, I have this in mind. I'll tell you. Okay. For now, I'm just explaining how it works. Tool registry, it is very important. Whatever tool you create, you put in a tool registry. This is one of, just write it down. This is a checklist that your tool should follow the tool registry guidelines. Otherwise, LLM will create any tool, and let's say get order status and create ticket. Only two tools I have, but an LLM might hallucinate and create, okay, get refund status, let's say, okay, and it will give the incorrect answers. But we are forcing LLM that, okay, don't jump, just go to the tool registry, understand which tools you have, just use only those two things which we have at the moment. If we add something else, then use that. Otherwise, I mean, you are limited to, it's kind of a enum or dictionary. Okay, for this you need Python 3 0.13, which is recommended. I'm not going to talk a lot about it. I expect you should know these things. If not, please, you need to work a lot if you don't know this. Okay, I'll be straightforward. Um, Either you can do the pip install, and for downloading Ollama. By the way, I wanted to show you one more thing, that this is the Ollama official website, and this is the Llama 3.2 model. Okay, um, you can use 1B model, which is this. Um, it will give you how many pulls are there and all those stuff information if you scroll and understand this live this website. But 1B I think would be good for you. It's a very small model. If you have ample space, go for the 3B model. Okay, I'm using at this point of time uh, the 3B model, or I don't remember which one I'm using. I think 3.2 in a way, but which version I don't remember, or 7B or 13B. These are also variants. Let me see which one I'm using. But yeah, but this is something I wanted to show you. It's simple, straightforward. Once you download and install this, if you go to your system, and I'm not sure if this is visible to you, in going in system tray, and could be hidden by my photo. But yeah, over here you will see Llama running, and and you go there. Okay, let me just open this, and how can you install this basically. So once the Ollama is installed, you can run this command, Ollama run Llama 3.2 in your terminal. Okay, as simple as that. You don't have to worry about what and all those stuff. Go for 1B tool, I would say. Okay, because you might have, most of us have these small scale mod systems, which will help us. By space, you mean RAM? No, no, both, both. Basically, space is just a 4 GB or 3 GB somewhere or something like that. So I'm not very much worried about that space, but the RAM itself, because model fully gets loaded into your RAM. Okay, and it simply kills you internally. So it loaded in a CPU in a nutshell, and then RAM is used to process that. In this case, I have the GPU, so I'm not very much worried about that. But if you are interested, you can simply open the command prompt. Okay, and once you open the command prompt, just copy this line. Okay, I'm doing this in parallel. Just put Ollama run 3.2. Okay, and just hit enter. That's it. Make sure you have Ollama installed or downloaded from its website. That's it. Once you do that, this model is up and running for you. Okay, and then you can test it by using the Ollama serve command. Which one is the serve command? I don't know which model I have. That's why I'm just not simply running it. It will unnecessarily install it. Let me see. Mm, yeah. So in env I'm using that. I have, okay, this is the one I'm using, Ollama 3.2 latest. Now this is going to be a little bit heavier. This is not a 1B model, so I would recommend you to use that. Okay, so let me just run this Ollama run. Yeah, Ollama has a UI as well, but that automatically get installed, and you can run from UI as well, not a big deal. Okay, so when you run this kind of command, it takes some time, and because it, otherwise it will download for you. In this case, it is asking me the question. Okay, because it's already installed, so I'll simply say hi and see how fast it responded me, because I'm using a GPU to run this. Okay, tell me how are you. Okay, so I'm just a language model, I don't have emotions, so on and so forth. So this is working fine, and you can see it's very answering me very fast, just because it is running inside the GPU. If this permits, I'll show you the GPU as well. Once again, yeah, I'm not sure how much of this would be visible to you. Yeah, so over here I'm using this GPU where this is RTX 5090 laptop GPU, and it is using Llama server exe. You can see over there. So that's where it fast for me. Now I'll quickly come back to this particular thingy. Here, just follow the instructions. Okay, step by step instructions. You must create a virtual environment in Python. If you don't know, I'll simply say one line that you create kind of a simple house where you keep belongings, or rather, you create a simple room in a big house of yours and you keep your belongings there. Okay, that's a simple virtual environment definition that it is all the libraries are within, and you can use these libraries for within that room only. If you go out, you cannot use it. To activate that, there are certain commands like you need to go to VNV script and activate. For Windows PS1 bat and activate, you can do that. You can pip install the run the pip install. Okay, let me show you straightforward. I don't want you to just simply get confused. Okay, so I'll run this command. Okay, let's do this. Okay, when you create the virtual, I have already created, so I simply skip this command. I will not run this. But what I can do is you can here you will see a VNV folder is created. So I'll make sure that I'll activate my environment. For that, I use to this go to this folder, find the scripts folder, and then activate. It's a it's a bash file which is going to activate your Python Python room for you, where you have installed all the libraries. Now, when you do this, you will see this is highlighted as .vnv. And you can give, by the way, any name. VNV is the name I have given. You can give any name. You can give Agentic RAG as well. Okay, so so that's how it works. And now, where were we? Sorry. Yeah. Okay. So then you just simply call this particular command pip install. Uh, Let me close this window, unnecessarily bothering. Okay. You just simply paste the command over here. Okay, and it will start introducing it. Okay, so you want Ollama, how can you use? Okay, I'll come to that. Okay, so let the setup help me with the setup, and then we'll go to that. Um, in this case, you install pip install requirement.txt. When you run it, it will simply start downloading your requirements. Okay, now this is how the Ollama will work. I'll come to that. Okay, now this is my environment file. Okay, I don't have any key, that's why I'm better positioned to share this completely. I'll first talk a bit about the environment example. Now this will answer you, Priya, that how we can use this. LLM provider is in this case Ollama. You can put Open API as well, OpenAI as well. Okay, so you just simply copy this and paste it here, OpenAI. Okay, and then OpenAI configuration. Your API key must sit here. If you don't know how to get one API key, you go to Open. You can simply search like OpenAI API key. Okay, um, uh, just simply search it and you will find this OpenAI platform. You log in here and you go to the keys and this one API keys, this page, but it will ask you for to log in, and once you log in, you'll get the key. Make sure you copy it so that you have it always with you. Okay, you simply paste it here. You know a key, right? You might know a key. Everything is like it's an alphanumerical character, like something like this. Okay, and then you use it. Okay, something like this, a number and alphanumeric character. Your OpenAI key should here go here. Yeah. Then the model, you can change the model with respect to what you want. Vector ID, store ID. Now this is important because this is blank for me because I am not using any embeddings model from the cloud. I'm using the sentence transformer and ChromaDB, and I bet you can use that in however system, whichever system you have. So don't worry about it. So just let's keep ChromaDB as a vector store. But if you want to use the cloud one, so you can again come to OpenAPI and you create, let's say, um, how to create vector store in OpenAI. Okay, it's fairly straightforward. Okay, you when you come here, you can simply use this page. Okay, and it will create a vector store for you. By the way, I have implemented this code as well, so it will automatically do it for you. You don't have to worry. But if you are using its cloud you'll store, you need a key as well for that, which you may use. But skip that part because it will unnecessarily cost you a lot of bucks. Download Ollama, it look like ChatGPT, just a model new system rather than online. A few options, download easy to understand. Thanks for you taking this. Okay. If you want to see Ollama, what I'll do is I'll put another step to just simply open Ollama. Okay. Open Ollama, and this is kind of a chat experience. Uh, you can you can do just like Chat GPT. Okay, when you install it, you will get this kind of window. You can search and simply do it. So these are the chats which are very for testing purposes. I have used multiple models. You can change the model from here. You can install directly the model, but make sure, I told you, right, use the smaller models with respect to the capability of your computer. Otherwise, uh, you will feel that okay, that's the mistake I did. For now I have this gamma 4 model and llama 3.2 model. You can simply talk it like we talk to chat gpt, exactly the way I work using a command prompt. This works simply like that, but it's a chat box. Okay, so hi, and you can, by the way, enable the web as well. um, these are not very good models, but they still give enough to work with. I'll use Llama 3.2. The coding, this Qwen 3 coder model is very good for coding. Not as good as Claude and all, but freely it helps you a lot. Let's say I will say that um, tools you are using. This is Ollama tool. I'm not sure if you're talking about this, but the other tools I'll come to that. So let's say hi. What is QA bash? Let's say. Okay, I'll say QA bash simply. I don't know how this is going to respond me, but I have enabled the web option for it. So it is searching for QA badge. It is searching for the results, and internally you can see what exactly is happening. And okay, let it. Yeah, here it is. The answer. It's a testing framework. So it is saying testing framework. Ishan, you need to do better now. This is not understanding it properly. Okay. Um, okay, but this is not a very good language model. So I'll just simply discount this, and it's free to use, so it is, I expect it to be wrong. Okay, okay, maybe the space. Okay, let's just try it out. I don't know where it answers from now. Okay, no, I mean community. Yeah, let's see. Okay, let it come. I'll quickly jump to this. Now the tools I'm talking about is these ones only, Ollama and which tools I'll tell you from this. Now we have, either you'll be using OpenAI, okay, and Ollama for your LLM, okay, which I've straightforward told you. Pydantic. Now this is very important aspect. Pydantic, if you don't know, I'll come to that. But Pydantic is something everybody misses out, but this is something has to be there for your agentic frameworks. As simple as that. ChromaDB you install directly from pip install sentence transformer. Okay. Now coming to sentence transformer, um, I'll tell you what is that, and I'll tell you what is Pydantic. The sentence transformer is something which is available on Hugging Face. It is the Python framework for using to creating your embeddings. I told you about embeddings. Every text goes in, can be um, converted into a number, and that number is called as embeddings. There are certain re-ranker or anchor models, but I will not confuse for now what is that. But for now, understand that everything, image, text, video, can be converted into a mathematics. For that, we have certain models, and sentence transformer is sweet, lightweight library, which will work like a charm on your computer as well. And that's why I've targeted this. There are different embeddings model, these transformer sentence transformer as well, types of it, but this is basically a simple one to use and simple one to understand. Okay, now one one good example, for example, once you install this sentence runner, you call it, and this is the model it uses. Okay, all mini LM. I don't know that versioning part. They might have done something. So this is a mini language model, you can say, which is getting loaded on your machine, which is quite okay. Okay, which is your machine can handle that, and you want to create the embedding for this. The weather is lovely today. It's so sunny outside. He drove to the stadium. I don't know what that mean, but or they are linked together or not. I don't know. But you simply call that model, encode these sentences, and then it will print the embedding shape. Okay, so this is how the embedding look. This is the embedding shape or embedding rather looks like, wherein you have um, sorry, my bad. This is not a embedding. This is a similarity. Okay, now what does that mean is weather is lovely today. It's so sunny outside, right? So weather and sunny outside, these statements are very much closer to each other, right? If weather is good, that's why it's sunny outside. Okay, or rather it's sunny outside, that's why the weather is lovely today according to this sentence. But they are close to each other, and that's where um, they should be spoken together. Okay, if we have to. He drove to the stadium. This is not something which is looking like, or maybe this is, but not directly. Maybe indirectly. He drove to the stadium just because it's sunny outside today. This could be the relation, but this cannot be. Okay, it completely depends. So these statements in that space will be near to each other, and this could be a little far. If you provide more context, then it makes a huge difference. But otherwise, I see this is far from these two statements. Okay, and that's where the similarity comes into the picture. It is trying to identify the distance between those sentences in that space which I spoke about. Okay, while talking about the embeddings, and that's how it generates the mathematical embeddings, and that's how the model answers in a way by understanding the context more. Okay, so this is the sentence and transformer. You can again come and understand more around this part with this. Now Pydantic. Okay, I'll speak as a provider. Hugging Face more reliable than Open Router. um I'll switch to Open Router, to be honest, because Hugging Face, there are a lot of anybody see, Open Router is more controlled version. Okay, they gave you more uh, profound LLMs, but Hugging Face you can simply upload your model as well. Hugging Face, I uploaded models as well on Hugging Face, so I'll still go for the Open Router. Okay, so for example, TONI Ramchandani, this is the model I created for my image generation. Okay, so I don't know if this works now because I haven't tested. uh, let's see this. Create a portrait. This is the, by the way, this is the image generation model I trained myself on my images. Create a portrait. Spelling, I'm not good with spellings. For now, this is very important. I need to specify the keywords. Okay, the keyword which I have given while this. I just need to make sure this model name is correctly written over here. For linked, I'm not sure if it is going to generate this or not because I have not tested. Or maybe it will ask me to log in or something. You can use it, by the way, by logging. Okay, so it will, if it works for you, it will simply create a portrait of mine. So my point is, I uploaded, everybody can upload, but Open Router is in a way a closed loop where you have those LLMs which are, I mean, properly tested and fine tuned and all those stuff. Okay. Now Pydantic. I'm not sure how many of you know about Pydantic. If you know, please write in the chat so that I understand. Or if you have come across this word earlier, if you use Python, then it's good. Okay, now what is Pydantic? You know, Python is basically accepts every if you, let's say, create a variable A, you can put a string into it, a equal to Tony, or rather a equal to a number, or maybe a equal to a list. Okay, and Python accepts this, no problem at all. But this is a problem. When you create an agent, then your input should be very much clear. Otherwise, you are giving yourself an ability to LLM to break things. You may give a list, okay, instead of a name, then LLM will break for you, right? It will create something out of it, and you will fail miserably. So by Pydantic, Pydantic is a way of writing Python code in which there are by default validations available. If you skip something, it will fail then and there. So the whole idea of controlling the agents is to fail safe, to keep it fail safe. Okay, if it is failing, let it fail. You don't use for serialization, deserialization config. Yeah. So it in a way restricts Python to do or to live within a controlled environment. Okay, you can say like that. So and it is basically fast because it's written in Rust. Rust is, again, I'm loving it as I'm reading about it. Very good programming language, specially designed for operating system where fast is something which is needed, speed is needed. So you can say Pydantic is a way of writing your Python code where it automatically handles your basically data classes and your code initialization, your type hints, okay, so on and so forth. But if you don't know, do read about it. Okay, this is very important. I'll give you this example. This is which is available on its website. So uh, you need to um, you need to give the proper way of writing it. So for example, id in this case, it has to be as int. Okay, you cannot, it should not ideally accept anything else. Name is a string, and if it is not provided, then take John Doe, let's say. Okay, and sign up is either it's a date time or none. Okay, and test, I don't know what is that. It's a dictionary with a string and positive intent. What is that? I don't know, but yeah, that's how it should be. If something goes changes outside it, it should fail for you. If ID is provided as name, let's say ID is a string, then it should then and there fail you without, I mean, thinking out itself that okay, we may go ahead with this name as well. No, ideally LLM will take it. If you don't do it Pydantic way, it will take it. Okay. So now this is about our requirements. These are the tools which we are using. We are using sentence transformer. We are using ChromaDB. We are using a rich utility, which utility will see yourself. We are using LLM providers, which are Ollama and OpenAI. And then let me just simply go to this. Okay. Now, if you want to start the Ollama, which I have already shown you, but you can simply start with Ollama serve, and then you can pull the model which you want. Okay, and then you simply need to store everything in your environment file. Okay, whichever model you are using. So I'll come back to this environment file. Now, because I'm not using Ollama, sorry, OpenAI, I'm using Ollama. So my LLM provider is Ollama, and use local vector store, which is true. Okay, if you want, I mean, if you want to use local store, then you can store them. Chroma persistent directories, ChromaDB. Okay, this is something you can rename it if you want. This is a simple name. So uh, this is my Chroma database. Now this generates uh, in a NoSQL format, the database itself. And then for Ollama, I have this model, and this is my model pointing towards this URL. So whenever you start Ollama, it internally creates a host which is running on this 11434 port by default. If it is occupied, you may change the port if you want. Or you can simply kill this port using some command from the command prompt, and you can use this as well. Now, Llama 3.2 latest model I'm using. For OpenAI, you can simply if you are using OpenAI, comment those which you are not using, in this case these ones, and uncomment this one. Okay, this is as simple as that. and then there has to be your open API key which you need to add here. Okay, now this is done now. This is our environment, and this is ready once we have these informations at hand. And by ready, that means that this is must have for our environment to be up and running. Now I'll quickly go to the framework now, and I'll explain you bit by bit and everything which what we are doing here, and what is important, and what is and why this thing is used, okay, while coding this. Okay, so let's understand this. I will simply maximize this. Okay, now future annotations, this is something important because if Python version changes, then you want should be in a position to run this code as well. Okay, it's a simple definition of it. There is a lot of internal insights, but if Python changes to 3.14 and there are a bit changes on how it takes input or type hints, so basically it supposes that kind of a backward compatibility. So this import is important. You might see every day, or which whoever is writing the code in Python is using this import, and that's for that. And there are certain imports like operating system, path lib, because I want to read write path, uh, .env to load my environment, which is in .env file, which is available here. Rich console I told you, we'll see over here. This console, if I write simply here, you will not like it. Okay, you will not be in a position to read it far better, and that's why we are using rich console. Okay, now data directory is my data. You can change in real world. You will see data lakes, and it is talking to a dbt store as well, but in this case we have a simple enough folder, so we are simply keeping it. Make sure you are on the right path so that it works, otherwise it will fail because of your path. So just make sure you are in the same working directory and you're following the structure. Okay, now seed OpenAI vector store. Now what is seed.kb file? Seed knowledge base. Okay, we want this knowledge base to be converted into our vector embeddings. Okay, in the meantime, if you have any questions, please feel free to write in the chat, or if you have any doubts or you want me to repeat something, I'll just do it. Okay, so seed.kb means knowledge base. I mean, you can name it like it anything you want, but with this I'm seeding my knowledge. Now this seed open AI vector store. So see, there are certain imports over here. Now this is very important point I'm telling you. Okay, most of the time thing fail because of this. These are imports over here, but in this case I'm importing OpenAI within the OpenAI method only, because this is seed. If I want to use a OpenAI vector data store to store my embeddings of or my data, which I have here in the form of embedding, I'll use this method. Okay, the system will automatically call this method. We don't have to worry. But because we are using Ollama, which is in our environment file, it will call the different method. Okay, now you will see one important thing from OpenAI. This import is going into this method, not outside the method, because it's a fail safe kind of a thingy. If I'm not using this, then it shouldn't be failing. Okay, that's okay. If I have not installed OpenAI's correct version, it will not fail because it is not using it. I'm using Ollama. Okay, so this is one thing which, in a way, more um, way of programming and engineering thingy, that whatever you're using, you keep those import within that method because it's an option, right? It's a router we will be using. So this should not fail unnecessarily. It should fail safe. It should fail if it has to fail, but that has to be in a controlled manner. Okay, and that's how it is. And then I'm just printing something, that I'm setting this vector store. My client is OpenAI. I'm calling the OpenAI library directly, and if you hover on this, you will find what it takes. You can provide ample information, but we are not doing it for now. You name a vector store. Okay, you can name anything. This is a barely a name, simple name I have given to this, and this vector store is actually storing our embeddings. Now it is using this client, which is OpenAI beta, because there are certain features additionally available in beta, which you may not find in proper vector store. So that's why I use this, although I'm not using this, as I said, but let's keep it like that. And you need to create this vector store name. So this is going to create a vector store. Now I'll just reiterate that this is for storing your embeddings. This data is converted into mathematical form, just simple definition, and those mathematical forms are stored in your vector store now, which is a cloud storage, which you will find on OpenAI cloud. Okay, and then it is simple that I am opening this data directory, I'm reading bytes, okay, and I'm uploading this upload and I'm using, okay, I'm uploading upload and poll method. Now this is very again important. um, this is kind of a concurrency or a way of async. If you know if you have worked on playwright or something, you might have come across this concurrency thingy, async IO library. So basically it will wait till the time it's uploaded. Now very important, because why should I wait, right? Why should I wait? So for example, you are cooking rice in your kitchen, okay, and you wash your dishes in the meantime. So you are not waiting, but and you are not doing parallel task, but you are using concurrency over there, okay. Something you did, now you have some time to respond, like that rice will respond to you after, let's say, 15 minutes. In the meantime, you're utilizing your time to wash your dishes, okay. So that is how the concurrency works. So when you upload, it takes certain time. So upload and pull method will do upload, and then till the time it waits, it go for the next file which is available in that, okay. And once you have that, your vector store ID will be updated from this, okay. Now this is going to then simply upload or rather print that this is your um, vector ID and blah blah blah, okay. Now similar thing, because I'm not using this now, so I'll simply just close this, and on the similar grounds, I'm using my vector store, which is ChromaDB, which is for local storage, which I'm happy to use, and I feel you should also use because for this experiment, okay. But if you want to, when you go to the um, at the enterprise level, you will definitely have something which is not on your local for sure, okay. Either you'll use data lakes or Azure functions, or I don't know what else. So here you will see again, I'm fail safe here. I'm importing my ChromaDB and utils embedding function, everything inside that, because I don't want this to fail because I'm not using it. Okay. So then similar to that, I'm reading this particular data function over here, and I'm assigning this ChromaDB folder where it stores the embeddings for me. Okay. Now it has the persistent client. Now persistent client means I don't want this to be in a temporary folder, but I want this to be in a permanent folder, which is ChromaDB, and don't change it unless I ask to do it. And that's where the persistent client comes into the picture, that this directory will always remain same for me, whether I can rename this directory, I can change this, but I must do it from here. Again, a way of writing your code so that it does not fail, because it can fail otherwise, right? So you simply putting a soft assertion that it should not fail over here. Now this embedding function, which is calling the sentence transformer embedding, I showcased you sentence transformer, and it has the model, which is, it can have multiple model, but this is the mini LM model, mini language model, which is very simple enough to use and easy enough. It will go easy on your CPU, so just do it. Okay. Now since you have 2 to 3 days, you are using a poll method. It is better to use batch method. OpenAI gives you a size. Yeah, you can do that. You can do that. I mean, you can do everything. It takes, the whole idea is to be concurrent. The whole idea, and again, depending upon the situation, if you are, um, um, if you if you are implementing something else, then we are seeing about return progress, but upload has already happened. Yeah, you are right on this statement. So these are certain ways. I mean, you need to decide, because we are running into a very small set of examples. That's where this thing helps. But the whole idea is to get more knowledge around how and what should be used in which case, okay, ideally. So if you know that, then probably you will be better at engineering your aspects. Okay, and if you don't know, don't worry. I mean, you just don't get scared with this, that okay, I don't know this and that, but you can always query the documentation which OpenAI or ChromaDB has for that, and you can use it. Okay, so every, see, a good engineer doesn't know everything, but a good engineer knows how to query everything which is useful. Okay, so, and once you do that, you will be in a position to use it wisely. So I always give an example of a of kitchen. If you know your kitchen, then you can cook well. If you don't know your kitchen, it's a mess, right? You will not be in a position, no matter how good cook you are. Okay, so you must know your kitchen. You must know your where to look for what. Okay, that is something, the core engineering aspect which comes into um, the picture. Okay, uh, and then again, if you don't know your kitchen, I mean, it doesn't make you a bad cook. It just, you're not aware. Okay, but then the right step is to be keep things at the right place so that you are using it quite wisely. Okay, so once you start doing this, how I do this in a way is, for example, I don't know, let's say, about this function. Okay, very simple. Now this is very simple. Let's say I don't know about this function, so I can simply go on the documentation of ChromaDB. I'll try to identify. If I'm not able to understand this, you use LLM to understand it. Okay, now these days, this Gemini, again, one very good feature I found, that this Ask Gemini comes inbuilt with this. So this helps me a lot. You can use it as well. This is very good. So maybe you can write summary of this page, and how can I use in my day to day Python code. Okay, so that way you can use these LLMs as well, um, to to help you better. Now similarly, I can do this with this research paper as well. Okay, simply, I'll this is already sharing this. I'm just summarize, or help me understand this logic. Okay, so this is the learning has been become very easy now. What is not easy is to put efforts. Okay, so for that, yeah, AJS Copilot. I mean, everything. I use Chrome more often, so I like this in Chrome, and I think this is better than Copilot, obviously. So, and again, you can create your own extension. That's okay. Um, but yeah, let's move on. I think this is what we have done so far. That we have this embedding function ready for us. Yeah, this is again important to try and this, what you call, the the accept functions. Okay, because if my collection is already there, or maybe if any existing collection, I don't know whether this is going to impact me or not, so I'll simply call a delete collection function, and then just delete it. Okay, and then I'm going to create new collection for my support document. So this is another fail-safe thingy. You don't know, you don't want your existing collection may be overwritten or corrupt, or you don't know, right? You don't just give an LLM an excuse to hallucinate. Over here, what I'm doing is fairly simple, that I'm creating my collection, deleting the old and creating the new one. Now while creating the new one, I'm using these embedding functions which we created using sentence transformer, and metadata is fairly simple. You can add more information around your collection, but that's okay. Now how I load documents, I'm going and asking it whatever the MD files are, read that only. Now this function is again in a way controlling the things, because if something else some user comes and modifies or either adds a new file, right, which you are not following, maybe it's a text file you are not following in that case, so you are keeping things very much clear that only MD files read, let's read only MD files in this case. In real world you can change that thingy as well. Now I'm creating the chunks with this. This is a simple for loop that every document it will take through the uh, I mean it will take every paragraph and will split at /n/n, means where there is a new couple of new lines are introduced, I assume that's a paragraph and that is going to be chunked and it will create a chunk for that. Okay, now I'm going to iterate through all the chunks. Chunk means I told you already that a document can be a big document, but LLM may not process that whole document in a way. So we create chunk and we create a chunk ID to each and every source so that it helps us give the answers better. Okay, and then it's a list of chunk. So there will be a ID, or in this case a list. Okay, and a metadata for that particular chunk. Yeah, so I'm creating the IDs over here. This is going to generate the ID for the chunk. Now we'll come, so far we are just creating our database. Yes, it is using the recursive chunking, but it will stop at every paragraph ends. So imagine like your paragraph ends and your ID will automatically change and you have now ID 2 for chunk 2. Okay. Now you can this change this chunk strategy. Chunk strategies is there are research papers on chunk strategies as well. I mean, there are sliding windows, chunk strategy, and a lot of them. But yeah, but for now, we are doing a paragraph chunking. That's it. Okay. So going back to know your kitchen, you should know how to chunk as well. Oh, it will not echo now because I was just moving. That is the problem I understood. Okay. Now over here, I'm calling this main function. So far, now just remember this thing. Whenever you are creating AI agents, you need to make sure what there has to be a fail safe. Whatever fails, let it fail. Let's not LLM invent it. So if my data directory is not existing, then print it that your existing directory is not found. Okay, if you don't write this, LLM may hallucinate. So these kind of checks are there which you put. Now you can create a strategy. You can create a list where you should put these checks. Data is obviously my go-to thing. If data is not there, I don't want LLM to just answer me. Okay, as simple as that. So that list will eventually grow when you run this into the loops. When you create something, it will fail for some reason. You will understand what is the problem. This is one of the problem people just ignore. If these data directories are not, it they doesn't exist, then you need to make sure they exist. Okay. And then if there are not any MD files in this case, another check. I told you that I am very much, I have to be confident that if this thing is not available, now this is a definition. When you create your agent, you create your definitions. Okay. Now the definition is all our data would be sitting in MD file. All our data would be in this data lake or in this object in Azure or wherever, right? So these definitions have to be very clear and those has to be handled. If that is not handled, it will hallucinate. Okay, so these are some of the kind of a way you do checks, soft checks, hard checks. Event-driven development starts from the day one. Okay, from the data itself. Now, now I'm giving an option that now this may not happen in real world, but I want to give you this option that I want to use OpenAI vector store, ChromaDB vector store, or a local one, or maybe invalid choice. Okay, again, this is very important because I want again fail safe here. If user press 4, I don't want LLM to do something which doesn't, it's not there, right? So I want this to be controlled. I want to use OpenAI vector store, press 1. If I want uh, this seed thingy, press 2, and so on and so forth. Okay, this is the simple function. You will see over here, what I've done is I have put necessary checks which people ignore. Now these are the fails which people ignore most of the times. Okay, so before creating something, you create a checklist that what you are going to control and what you are not going to control. Okay, now I'll simply run this file. Sorry, guys. Okay, I'll simply run this file. Now I'll show you two things. One is rich console. You can see the text in the colors and all those stuff. The numbers are in colors. I don't want to use OpenAI vector. I don't want to use both. I don't have that. I'll simply do 2 and hit enter. Now this is forcing me to use something. Now this is very important. Forcing you to do something so that it makes sure that you are not doing something which is harmful for the system, and LLM can take disadvantage or advantage unknowingly or knowingly, I don't know. Yeah, so now why it is load you may be wondering why it is loading these weights. Now these weights are coming from Hugging Face for the sentence transformer. Sentence transformer is free to use. That's where Hugging Face token is mandatory, but in this case it skips for that this particular library, and that's why I don't want you to go and worry about Hugging Face token. But if you want to use some another model where Hugging Face token is mandatory, then you need to grab one and you need to put in your environment file. That for later, if you want, we'll connect that. But now you can see it has indexed four. It has created 4 chunks from the FAQ, 6 chunks from the order.md file, return policy. It has 2 chunks, 2 chunks from the shipping policy. Now I told you the chunk will go on the double slash, which is a paragraph. It has indexed 14 document chunks. Okay, and now it will again see. This is important. This is asking you to make sure that you have these particular thing in your environment file. Okay, now this is another check, which is a soft check, that a message which Python gives giving me, this program giving me, just to make sure we are up and running. Okay, if nothing is there out of this, this will fail. Knowledge base is complete. Now you can run Python app.py. Now knowledge is created. Whatever knowledge we had is transformed into this chunking strategy and embeddings and all those things. Okay, I'll now go to tools.py file before going to app.py file. Now app.py file is our primary source which needed, but c.kb file was for chunking and all those stuff. Tools is for the tools which we allow our this framework to use. Okay, uh, future I told you about that. Data classes. Now what is a data class in Python? when you uh, when you might, if you use Java, then you create a constructor and you assign some default values to your constructor, right, at times, or you initialize those variables. In Python, fortunate or unfortunate, that is not available, and that's a major cause of failure. I already told you that integer can take as a string and string can take as an integer, and to make sure these constructors are working fine, you need to write a lot of code, getters and setter and all those things. These data classes will make sure that you don't need to write a lot of code. The boilerplate code for the classes is handled by this data class. Okay, and that's why it is very important. So I must say that if you are writing any tools for AI agent, you must use these data classes and make sure that you have like import any, so that in some cases you don't care about the outcome, right? Maybe an LLM respond in the form of list, in the form of bullet list, or in the form of, let's say, an array or a text. You are okay with that. Okay, so sometimes I am okay, but sometimes I'm not okay with that. So these terminologies you should understand while creating the orders. Mock orders. I'm creating a simple database because I want this to understand, these tools to understand that this is the only way you will find my order details. There is no other way. Okay, there is no other way. If there is something else, then that means there is some hallucination and we are avoiding that. Okay, so you need to make sure that whatever you give to your tool, there has to have schemas. Now this is the mock order schema. This has to follow this route. Okay, if I don't give this, tool may assume, and I don't want my tool to or tool will not assume, but LLM will assume while using the tool. I don't want any assumption over here. I want fixed and straightforward thing schemas that okay, this is how it should look like, and that's it. I'm very hard bound to this. Okay. Again, that's where most of the things fails because people simply don't give enough information to the tools or to the LLMs. Okay, and they exploit that. Here I am giving very crystal clear. Now my mock tickets. So for example, if I have to create a ticket on one order ID, now this mock is not a good word, but this is something for demo only. So I'm creating a list of a dictionary and a string and any type. When I say any type, string would be my number of ticket, and then any could be the description, right? It could be a number, it could be a statement, it could be anything, right? It could be a list of products, right? So on and so forth. Now, data classes. I told you that's an annotator which you use to write the boilerplate code. And by the way, if you have any questions, you can feel free to ask in the chat. We are forcing our tool result to be the form of a string, and the the input should be string or the name should be string, and the output has to be this like this. If anything beyond this, I'm not going to accept that. It should fail. Okay. Now these are again some checks which everybody should do while creating those agents. Okay. Now I have ideally the actual tools now. Get order status. Now it accepts one order ID. Okay. And it results me the dictionary of my order details. Now mock orders. I have given the mock orders just to understand it. Okay. Now this is very critical in my tool, if not order. So that means if my order is not following the schema level of mock orders, okay, then found should be false. Okay, no ID found with that ID. Okay, and else it should return me and unpack the order itself with the ID which found. So double star is going to unpack the whole order, which is by which this particular when I say unpack, so this is the dictionary it is going to unpack for me. Okay. So with this tool is pretty much clear what it should do. This is pretty much clear what it shouldn't do. Okay. And similar to that, create a support ticket. Now I'm not going to explain this, but this is on the similar lines that I'm going to do the strict typing over here, that how my tool should take what do you call the inputs and how should it responds. Okay. Is this clear so far? Any doubts? If not, we'll move on. Tool registry. Okay. Now I told you this is very important. Again, tool registry is something where you maintain your tools. If I add new tool, deliberately I need to put here. If I miss to use that, miss to write over here, then my LLM should fail for that. Okay. This should not invent the something which is not existing. So this tool registry is very critical 99% of the times, or rather, I don't say 99% of the times, but people who success in demo but fail in real world, 99% of the times they do this mistake. They don't create a tool registry and they fail in a way to have LLM inventing or creating its own tools and answering and hallucinating. So this is how I'm controlling everything. Okay. Now this is how you should do ideally create tools. This is how you ideally. I mean, when I say ideally, I mean you can add more features to it, but there's a bare minimum things you go. Now app.py. This is my main entry point. Okay. This is where my order support agent lives. It is basically it has this agentic system as well. It loads the OpenAI or Ollama provider, and then it there are all the imports are here because we want to use them. Okay. Now this is system prompt. I think there was a question that how we are going to use this orders or what. I don't remember the question, but I forgot it. I forgot it. If there was a question on this, if you can write for me, I can answer that. But yeah, but here I'm controlling the system prompt itself. You can again modify this, or you can create a multi-system prompt, another way of prompting. So in this case, this is another very critical point where you need to control your LLM basically. So you are an order support assistant for an e-commerce company. You can do these things, but these are the critical rules you need to follow. Okay. Now, if I simply write this, you are an order support assistant for an e-commerce company. Okay. This may work for you, but this is going to fail for sure in long term. Excuse me. Yeah, and that's where these critical rules and what you can do has to a limit. Okay, this is very important. If you don't add these things, you miserably fail. Okay, now these critical rules are the business logic, which a BA can help you, SME or yourself. You can create those rules, which are, if you know your business well, you can means you are allowing what to do, and you are forcing an LLM. And again, you can add another section you can't. Okay, yeah, I remember the question that somebody was asking that if what if the order doesn't exist, how my LLM should respond to that. Okay, in this case, this controls that narrative, and to control more, you can add another line. You can't invent anything which you don't know. Okay, or maybe of that sort. Okay, you need to control from here. Agent action. Now this is the class which is the abstract class. Okay. Now again, this is Pydantic way of forcing the LLM to use these actions only. When I say uh, when I say base model, so base model can be OpenAI or Ollama, whichever you want to use. Now this action is answered directly. Get order status, create support ticket, and ask clarification. You are not allowed to perform any action beyond this. Okay, this is again controlling point, and this is Pydantic nature of writing the or creating the agent classes or the agent actions. You can have order ID or you cannot. Simply a user cannot give you order ID. That's okay. If it is not, then assume none. Don't invent. If it's given, it's a string. Default is none. If it is not given to you, okay, yeah. So I'll quickly cover this now. If it is not given to you, then, but why I'm explaining this so far, because this is how you control LLM from hallucination. Okay, and most of the times people are not going to tell you about it, and you can and vice versa. I mean, applicable for everything. Now, LLM provider over here, we are replicating, or rather, we are using this class, implementing this class for the OpenAI provider. Okay, and it is going. This LLM provider is going to give us the search knowledge base. So basically, it is going to give. We need to implement this search knowledge base when we use the LLM. Okay, and then these build tools. These are like methods which are only applicable to this class, and there's a strict typing on this. Basically, it's a function name is this, what the description, and what it takes and how it takes basically. Okay, so these are strict typings. If you read this, it's simply straightforward. You can add or remove whatever you need. Okay, and then message to the input. Basically, this is again over here I'm controlling my method way of talking to the input basically, and generate response. Again, I'm controlling how I generate response over here. So there are messages, their context knowledge, so on and so forth. Okay, I'll and then this is the Ollama provider, which where I'm pulling this latest model, 3.2 in my case. And I'm not going to explain this a lot because this is just using what we have created so far. Okay, and then the generate response. Basically, this is how you control your output, where what kind of a result you need from the LLM basically. Okay, if it needs to use any action, then it should call an action. Okay, otherwise not. So that is something how you control your thingy. Now, now in this case, there's a router prompt. Okay, when I say router prompt, this is important because sometimes user may not give you right information, right? So you need to reach out to the user or human or ask for the clarification, so on and so forth. And that's the prompt. This helps in this case. So many lines. I simply cannot cover all of it, but the gist is that over here everything. Yeah, one important point. Tool name is not in tool registry, then error unknown tool. Don't invent anything. So the whole idea is that whatever we are using, there are controls at prompt level, there are controls at tool level, and there are controls at every possible layer which we are doing. Now I'll simply run this Python. In the interest of time, I'll run this python.py. Okay. When I run this, I have created certain questions for it. So let's say how long. Okay. So now it is loading the weight. Again, sentence transformer is loaded. Now let's say I simply ask a question: how long does shipment take? Okay. Depending upon how your model is performing, it is going to answer. The agent is assistant. According to our shipping policies, it takes 3 to 5 business days, so on and so forth. So it is asking. So you ask the question and it is answering you. Okay. Let's check the order ID 1001. Um, okay. Let's check this order. How it is. So we'll close this soon. But yeah, order ID has been shipped and is currently being delivered. The estimated date is 5 May. You can track with this track number. See how this is responding. In this case, let's say if I ask where is order, okay, let's do something fishy over here. Okay, check this order. Now this should fail. Okay, I don't have information. So it is very clear in terms of what it has and what it does not. So we'll just simply check one last thing. Um, I received this damaged product. So when I do this, so it says we apologize for inconvenience. Happy to assist you, and it is creating the ticket with this ticket ID. Okay, and it's currently open. So we have this agent up and running. I expect you to play with this, install this, and put your comments. If you have any doubts, I'll help you. Um, this is it what I have to show today, and if we continue on this, there is a journey that in day two basically I'll add traces, uh, tool call visibility and retrieval visibility and decision evidence. Does it handle the fuzziness? What if the structure of the query changes? Yeah, so we are using Pydantic. I'm not sure what structure you have in mind. If you put in the chat, I'll just simply test it now. But this is how we create certain things. But how to evaluate that? For that, in real world, we use something called as traces and observability. If you know about it, if you don't know, I'll explain that when we connect again. But but I hope you enjoyed this. If you Devin, if you can, let's say we just give an order number. Yeah, let's try that out. Okay, so let's say I'll copy this and I'll paste it here. Okay, and this is again my incorrect number. So yeah, so see, it is answering properly. Now why it is answering? Because we have strict definitions, which is most of the time people fail to do it. Now interestingly, it is very simple, but but it's kind of a thing that everybody ignores, and that's where the system fails. Okay, let's ask a stupid question. are you today? That's a general question. I'm functioning properly, ready to assist you with you. Yeah. So see, this is answering you quite well over here that this is not something it is entertain. It should entertain, and this is not giving you. Okay. Maybe I can see that. Have you tie up with Amazon? This is a very stupid question again, but could you please share the missing details? So it does not understand what you want to ask, and that's where it is also um, giving you the correct answer. It is not hallucinating over here, right? So again, we are not at the state that we are in. We have generated a very good agentic RAG, but what we have done is basic house checks that my when I leave my house, my door is locked. When I leave my house, my gas connection is closed and everything. So it is a last minute check. When I say last minute, not a last minute check, but kind of a thing which you have to do while creating an agent, which nobody talks about most of the times. And it's the basic reason why you will hear the sentences like 95% of AI agents fail. Okay. Um, I'm done with that. In the next session, if you help me with your availability, then I'll introduce you to tracing and observability. Yes, it does store the context as I said, but as soon as you do the control C, it will stop. Okay. I'm not using any memory, but I'm storing the history. If you read app.py file once again, you will find that over there. Okay. Let's see that. What happened to it created a ticket, right? So let's see. Again, I have not tested as well. I'm just doing it now. What happened to ticket number? Um, so it is asking me what is your order number. Okay. So basically it is failing over here. It should give me the ticket details. So it is failing. That's a defect. That's something which, yeah, we found one defect. It should fix. It should not operate like this. Now, when we go into the traces and we go to the evals, we'll see how to fix this. Can you please open? I cannot because there is no native way to open this. You need to install the SQLite to open this. This is a JSON file. If I have to answer you in a way, but this, or rather, it's a list of numbers, arbitrary numbers, which you may not be in a position to understand. So it has the byte codes, okay, for that particular thingy. But if you still want to see, then just simply go and check that um, how embeddings look like, how embeddings look like in vector store. Okay, so you will see something like this. You will see something like this, okay, which you will not understand. Thank you so much. I hope you enjoyed this, and I enjoyed myself. Uh, yeah, we'll connect if you want. We will run another session. And by the way, I really want to thank Ishan, Gaurav, Amol. They helped me a lot testing these kind of setups and put the energy which, and they bring the energy. In fact, they're not only putting the energy, but they bring the energy which which everybody needs. So thank you a lot, guys. I don't know how to say that, but yeah, but that is something really helped me. And I was not very good with this tools called OBS and StreamYard or whatever, because I'm doing this for the first time. And these people, I'll pat on back on them because they stood up and they helped me in every possible way. Yeah, I would like to teach you more, but then I need a similar kind of enthusiasm from you. Now, Ishan, we can do one thing, that if these people like this, we'll continue only if they do something on their machines. Otherwise, I mean, I'm just speaking and you are not doing it. That is not going to help you. Okay, sure. Thank you, guys. I will take a leave now. Mm, sure, sure. I am SV Pandey. Sure. This is, please do that. Yeah, you guys, bye for now. My son is not well as well, so I'll just quickly jump to the different responsibility. Okay. I don't know how to stop this. I'll just stop this.